All right, so we have more P6 stuff on graphing. So in this section here, we're going to try to write the equation of any line that is parallel to this given line. So you have a ton of different options here because we know that if lines are parallel, they must have the same slope, right? So we're going to write parallel lines must have the same slope. All right, so I look in this equation and I see that my slope is a -3. All right, so -3 is the slope of this line, so I can write the equation of any line. Y equals -3x plus 1 would work. You could do y equals -3x, that would work, right, plus 0. You could do y equals -3x minus 10.261, right? You could do anything as long as it has the same slope, it's going to be parallel. Next, we want to write the equation of any line perpendicular to this given line. So perpendicular slopes are opposite reciprocals. All right, so perpendicular lines have slopes that are opposite reciprocals. All right, so if I look at the slope here in this one, we see that we've got a slope of 1/2. So the opposite reciprocal, opposite meaning I change the sign, so this is a positive 1/2, so I know my answer is going to have to be a negative. And then the opposite of 1/2 is 2/1, and we know that 2/1 is just 2. So we could say y equals -2x plus, we could use 11 again in this case actually because it just has to be perpendicular. We could say y equals -2x minus 1. We could say y equals -2x plus 50, right? We could say anything as long as it has an opposite reciprocal slope. That means that it's going to be parallel to that line right there. All right, next up, we're going to write the equation of a line that is parallel to this given line, but it also has to go through this point -6, 0. So we kind of have two requirements now. So when I think about this new line that we're going to make, all right, here's the new line information. The slope of the new line, well, we know that the slope is wanted to be parallel, so it has to have the same slope as my given line. So I know the slope has to be -4. And if I'm going to write the equation in slope-intercept form, we know that we're going to have to find the slope, but we're also going to have to find the y-intercept. Now, right now, I don't actually know the y-intercept. Okay, I know a point on the line, x, y, but I don't know what the y-intercept is. Luckily, though, we have enough information because if I write y equals mx plus b, I know all of these things except for letter b, right? I know that we've got a y value, right? Here's my y value of 0. It's going to go in right there. And we've got an x value of -6, which will go in right there. And we've got a slope of -4, which will go in right there. All right, so if we plug in all these values, we've got 0 equals -4 times -6 plus b. This is going to be 0 equals 24 plus b. So then if we just subtract 24 on both sides, we find out that b is -24. All right, so if we look at the information we need, we found the slope and we found the y-intercept. So the equation is going to be y equals -4x minus 24. All right, and that's going to be the equation of the line that is parallel to this line right here, and it also goes through that given point. Again, if you're if you kind of want a visual to go along with this, you can go ahead, go to Desmos. You can go ahead and graph this line, right? Go ahead, graph that line right there. Graph this line here, that way you're going to see that they're parallel to each other. And then if you graph this point, -6, 0, you'll see that this line does in fact go through this point. All right, so Desmos is a great tool to use just to visualize kind of what's happening and just to confirm your answer as well. Next up, we're going to write the equation of a line that is perpendicular to this given line, and it also goes through this point. So this is not in slope-intercept form yet. So first thing I'm going to have to do is change this into slope-intercept form. So I'm going to go ahead and I'm going to add 3x on both sides. That's going to give me 5y equals 3x plus 20. And then we're going to go ahead and divide both sides by 5. Remember, when I divide both sides by 5, I have to divide every term by 5. So y equals 3/5 x plus 4. All right, so this line right here is the same as this original line. All right, we've made it look a little bit different, but these are the same lines. If I were to graph these both on Desmos, they would be one on top of the other. It's the same line. So what I want to do now is think of the equation of a line that is perpendicular to this. All right, so perpendicular means that my slope is the opposite reciprocal. So if I take 3/5, I'm going to make it negative 5/3. All right, and I'm looking for the y-intercept. We don't know what the y-intercept is just yet, but I do have a point that it goes through, right? We know it goes through negative 5, 2. So negative 5 is an x value, and 2 is a y value. So what I can do is I can take my y equals mx plus b, slope-intercept form, and we have all the information we need, right? We know that the y value is 2, so I'm going to replace the y with a 2. We just found the slope is negative 5/3, so I'm going to replace m with negative 5/3. And we know that x is negative 5. And we don't know what the y-intercept is just yet, so plus b. So I'm going to go ahead and multiply. 2 equals 25/3 plus b. And then I'm going to go ahead and I'm going to subtract 25/3 on both sides. All right, 25/3 minus 25/3 cancels. And so we end up with 2 minus 25/3 equals b. Now, in order for me to combine these two terms, I have to make sure they're both over 3, right? They have to have the common denominator. So I'm going to change 2 to 6/3, right? Because 6 divided by 3 is just 2, minus 25/3. And 6 minus 25 is negative 19. So negative 19/3 is your y-intercept. So this is great, right? Because I know the slope of my perpendicular line. I know the y-intercept of my perpendicular line. So now we can write the equation. Final equation, right down here. Final equation is going to be y equals negative 5/3 x minus 19/3. All right, so this is the final answer. Again, this is the equation of the line that is perpendicular to this given line, and it also goes through this point. So again, I would recommend opening up Desmos, giving it a shot, graphing this information, and then you're going to confirm that it's perpendicular and does go through the point negative 5/2. All right, next one, we're looking for what would x have to equal such that the slope of these 2 points equals negative 1/3. So I know I've got 2 points, so there's my x1, y1, x2, y2. So we know that the formula is slope equals y2 minus y1 over x2 minus x1. All right, so there's the slope, and we know that this slope has to equal negative 1/3. All right, so I'm just going to simplify the numerator a little bit here, and I'm going to make this 3 over negative 2 minus x equals negative 1/3. Now at this point, I know that if I have a fraction equal to a fraction, I can just do some cross multiplying, right? Remember, cross multiplying is always an option when I have one ratio equal to another ratio. We call this a proportion. So I'm allowed to cross multiply here. So we're going to do negative 1 times negative 2 minus x. So you really have to think of this as negative 1 distributed to the negative 2 and the negative x. All right? And then on the other hand, we've got 3 times 3, which we know is 9. All right, so if I distribute that negative 1, negative 1 times negative 2 is a positive 2. Negative 1 times negative x is a positive x. So now I'm going to go ahead and subtract 2 on both sides. And so we find out that x equals 7. All right, so 7 is the value of x that would make the slope equal to negative 1/3. All right, and you can just try it out too if you want. If we were to plug in, if we were to take this 7 and plug it in right here for x, we would get, 7 minus 4 is 3, and negative 2 minus 7 is negative 9, and we know that 3 over negative 9 is the exact same as negative 1/3, right? It's just reducing a little bit. So we can verify that we got the correct answer. So if you ever want to verify, feel free to do that just to make sure you did it correctly. All right, the last one, we're asking if AB and CD are parallel, perpendicular, or neither. So I know that if they're parallel, they're going to have the same slope. If they're perpendicular, they're going to have opposite reciprocal slopes. And if they're neither, then they're just not going to have any special relationship. So if I look at AB, all right, that's these first 2 points right here, I'm going to look at the slope. So the slope of AB is 10 minus negative 2 over 3 minus 6. So this would give me 12 over negative 3, which is a slope of negative 4. All right, so between A and B, that slope's going to be negative 4. And now I want to try out CD. All right, so the slope of CD is going to be, again, y2 minus y1, so 17 minus 14, over x2, which is negative 7, minus x1, which is 5. So if we look at this, 17 minus 14 is positive 3. Negative 7 minus 5 is negative 12. This reduces to be negative 1/4. So if we look at these two, well, they are reciprocals, right? If I flip 4 over 1, that becomes 1 over 4, but they're not opposite, right? They're both negative, and so our answer here is going to be neither. All right, these are not going to be parallel, nor are they going to be perpendicular to each other. All right, and if you went on Desmos and you graph these 4 points, if you wanted to, you could find the equation of AB and the equation of CD, and then you'd definitely be able to see that they're not perpendicular. But even by graphing these 4 points, you should be able to kind of clearly see that there's not going to be a perpendicular relationship there, all right? Or parallel relationship for that matter. So that is all of the chapter P6 on the graphing stuff. When we get back, we're going to look at the midpoint and the distance, all right, which kind of ties into what we talked about last year in geometry.